Greetings. So today I wanted to share with you a cool visualization of completing the square and how that rule works intuitively. So when you're solving quadratic equations, sometimes you can't just easily factor them and you have to use a strategy called completing the square. So let's look at a problem that needs that. So let's say we have 3x squared plus 5x plus 2 is equal to 0. Alright, so it looks like this is not going to be so easily factorable as if we just had, like no integer here and integers there. So first thing we do, let's divide everywhere by 3. Okay, so now we have x squared plus 5/3 x plus 2/3 is equal to 0. 0 divided by 3 is still 0. And yeah, so if we were to try to factor this, we would be looking for a number that multiplies, or we'd be looking for two numbers that multiply to 2/3 but add to 5/3, and that's hard. I don't know what that would be offhand. Okay, so we're going to use something called completing the square, which says if you have something that looks like this, x squared plus bx, you can write that as x plus b over 2 squared minus b over 2, and that thing squared. We have this completing the square rule that we can use. Alright, and this is what I'm going to visualize here in a couple minutes that I think is so awesome. So continuing with this example, let's go ahead and move that 2/3 to the other side. So we have x squared plus 5/3 x is equal to negative 2/3. Okay, so now using this rule here, we have something that looks like this, right? X squared plus bx. In this case, b is 5/3. Maybe if I put that in parentheses, it helps emphasize that a little bit. And we can rewrite it like this. Alright, so x plus b over 2, and our b is 5/3. So what is half of 5/3? That is 5/6, right? Multiply 5/3 by a half squared minus b over 2 squared. And b over 2 we already said was 5/6. 5/6 squared is equal to, this pen, negative 2/3. Okay, so now we simplify. X plus 5/6 squared minus 25 over 36, right? You can square the top and bottom, is equal to negative 2/3. We'll move that to the other side. X plus 5/6 squared is equal to a positive 25/36 minus 2/3. And it looks like our common denominator here is going to have to be 36, right? So just rewriting the right side, 25 over 36 minus something over 36, and 3 times 12 gives us 36, so 2 times 12 gives us 24. Okay, so this gives us 1 over 36, and this whole time, by the way, I should be rewriting that. I'm too lazy to. X plus 5/6 squared is equal to 1 over 36. So now at this point, the way you solve it is, of course, take square root of both sides, which gives us x plus 5/6 is equal to the square root of 1 over 36. This actually comes out not too bad, 1 over 6, right? Plus or minus, of course, because we've taken the square root. Either you could square a positive 1/6 or a negative 1/6 and still get to 1 over 36. And so now our final solutions are x is either negative 5/6 plus 1/6 or negative 5/6 minus 1/6. Okay, so that gives us negative 4/6, which reduces to negative 2/3. Gosh, there's a lot of work in this problem. And that one is just negative 6/6, right? Which gives us negative 1. Alright, so there's our two solutions, finally. Whew, but we couldn't have done it without the help of completing the square all the way up there. Right? So let's look at this. Let's look at a cool visualization of this that I've been chatting up the whole time. So let's say that this is an area. Right? So x squared is a square. If that's the area, right? It's x by x in length. Okay, so bx plus something that is bx. So let's say something like this. Right? So it's this length is still x, right? Because it's b times x is that area. But this length, let's say, is b. Okay, now we're trying to make a square out of this, a perfect square. Okay, it's kind of hard to do, but let's cut this part like this, okay? And let's take half of it and put it here, and the other half, and we'll put it down here, and we'll see what that looks like. You can probably visualize that. I'll try to draw this the same as best I can. XX, okay? And so now we have this piece here, which is, of course, b over 2. It's half of b in its length, and the other half, put here. And this is not to scale, as one of my professors used to say all the time. Not to scale. Okay, so now we've come close to writing this as a perfect square, right? If we had this little piece here, we could just write the whole thing as, what is this? Well, this is x plus b over 2. Add those lengths together. X plus b over 2, right? Squared. Isn't that the area of this whole thing? If we had that? But we don't quite have all that. We're missing this little piece, right? We have to, wait for it, complete the square, right? Maybe that's where the name comes from, right? People do name things smartly sometimes. So, because we don't have that piece, and we've just said the area of the whole thing, including the piece, we have to account for that by subtracting that area off, right? What's the area of this little box that's missing? Well, that area is that length there, which is half of b times half of b. And that is where this comes from, and I think is a beautiful visualization for why it works, that sadly I think is not often shown. Alright, well, if you have any requests, I'd love to explain stuff. And I guess that's all I have to say. I hope you like math. I like math. That's all. Thanks for watching.